Okay guys, let's look at these two open responses. The first one is on differential equations and slope fields, and whenever you're asked to draw a sketch of a slope field, you want to find out what the slope is at the points that they're asking you to plot. So here there are 12 indicated points. So we're going to make a slope field for these 12 points, and the way that we're going to do that is to set up a table of values. Now it's not like your typical table of values where it's like, here's your x and here's find your y value. It's a table of values with given an x value and a y value. So if we're given an x value and we're given a y value, let's have x's run this way and y's run this way. So the x values that we're going to be working with are -1, 0, and 1. And the y values that we're going to be working with are -2, -1, 1, and 2. So -2, -1, 1, and 2. So notice that there is no y value of 0 here. So now I'm just making a table of values. Okay, so if we plug in -2 for y, you can do it in rows, you can do it in columns, it really doesn't matter. But what I'm doing is I'm plugging in -2 for y. So I've got -2 times x divided by -2. Now if my x value is -1, let's say, then I would have +2 over -2, which would be -1. If I plug in 0 for x, I'm going to get -2 times 0. And if I plug in 1 for x, I'll have -2 over -2, which is a +1. Alright, now let's plug in -1 for y. So -2 times what x value over, we're plugging in -1. Okay, so if we plug in -1 for x, -2 times -1 is +2. So we get -2, because we're dividing that by -1 there. 0 is a nice one. And then -2 times 1, +2. So I think that we can start to see a little bit of a pattern that's developing here. Now, if we plug in 1 for y, so we have -2 times what x value over 1. -2 times -1 is +2. 0. -2 times +1 is -2. And lastly, what color haven't I used yet? Gray. -2 times what x value divided by +2. So -2 times -1 is +1 divided by 2 is 1. 0, and -2 times 2 times, -2 times 1 is -2 divided by 2 is -1. Okay, so now we just need to plot the slopes, these slopes that are here. So if we want to plot these slopes, if we're looking at let's say the green ones, at the point -1, -2, so x value -1, y value -2, my slope is -1. And if I want to go down the rest of this column, at the point 0, -2, I have a horizontal tangent. I'm going to zoom in on this so my points are a little bit bigger. At the point -2, +1, -2 here, I get a slope of 1. Now the purple ones, my slope is -2, 0, and 2. So this is a little bit steeper, still 0, and then more steep on this side, positive. And then the light blue ones, here I have +2, 0, -2. And lastly, silver ones, -1, 0, and 1. -1, sorry. So I know that it's hard to tell, and you just need to kind of think about what the slope of 1 looks like and whether it's going to be steeper or shallower than that. All right, so there's part A. For B, to write the equation of a line, we need two things. We need a point and we need a slope. Well, we're told that the point is x value 1, y value -1. And then we can look at our table of values. When we have an x value of 1 and a y value of -1, our slope was 2. So our point is x value 1, y value -1, and then at that point the slope was 2. So the equation of our line is y plus 1 is equal to 2 times x minus 1. And then it asks us to use this line to approximate the value of f when x is equal to 1.1. So if we want to approximate this when x is equal to 1.1, we're just going to plug in 1.1. We're going to plug in 1.1 for x. So y, let's do red, y plus 1 is equal to 2 times 1.1 minus 1. Point 1 y plus 1 is equal to 2 times 0.1. We're just going to move that decimal point over 1. And then when we subtract 1 from this, minus 1 minus 1, y is equal to 0.8. Negative 0.8, sorry. Okay, so there's the approximate value of y. In order to do the last step of this, which is usually worth the most points, so steps 1 and steps 2 are usually about between 3 and 4 points, and the rest of the 9 points are made up on the last step, which they deem to be the most important. So find the particular solution to the differential equation with the initial condition. So if we're looking at our differential equation, let's just write down this stuff and I'm going to do it over here. So dy dx is equal to negative 2x over y. And we also know that the initial condition is f of 1 is equal to negative 1. Okay. So we're solving the particular solution. The first thing that we want to do is we want to separate our variables. This is a very important step. The College Board thinks it's the most important and doesn't award you any points if you don't do this step. So to separate our variables, I'm going to rewrite this as y times dy is equal to negative 2x dx. We can now take the antiderivative of both sides. So take the antiderivative of the left side and the antiderivative of the right side. The antiderivative of y squared over 2, is equal to negative 2x squared over 2, or just negative x squared. We have to add in our constant of integration. Now I know that we could have one on the left side and one on the right side, but we write it as a single constant on the right side. Now we were given the initial condition. When x is equal to 1, y is equal to negative 1. So using our initial condition, let's put those values in. Negative 1 squared divided by 2 is equal to negative 1 squared plus c. Now let's be a little bit careful when we go to do this because you're gonna want to On the right side, call that positive 1. But here we have negative 1 squared, which is equal to, we're only squaring the 1, so this is still negative 1 plus c. Add 1 to both sides, add 1 to both sides. C is equal to 3/2. Now that we know that c is equal to 3/2, let's come back up here where we have y squared over 2 is equal to negative x squared plus 3/2. So now I've substituted that value for c in. We have to do some work to solve for y. Y squared is equal to, I'm going to multiply both sides by 2, so I get negative 2x squared plus 3. To solve for y, we're going to take the square root, so take the square root of the left side, take the square root of the right side. Y is equal to plus or minus the square root of negative 2x squared plus 3. Now, because we were given that the y value was negative, here we have a plus or minus, but we want the particular solution for this. So because our y value in our initial condition is negative, y is equal to negative square root negative 2x squared plus 3. Okay, I know that that was the first one of this type that we've done. The bell just rang, so let's end it here, and I'll do another video for the second example.